The first model that we're going to look at, and in fact the only growth model that we'll look at in great detail, is named after Robert Solow, who was a Nobel laureate. And in some ways, this model simplifies what we did before because we are not going to have a leisure choice in this model, and we are getting rid of the government. But this model then is going to instead add dynamics, whereas the previous model lasted only one period. This model is going to last many, many periods, an infinite number, in fact. And we are going to take population and labor force growth as given and growing at a constant exogenous rate. Consumers, though, are going to make a savings decision, which is going to mean that we no longer take the capital stock as fixed as we did before. So we now are going to have a savings decision that gets made. Okay, so now this is really the simplest possible model of economic growth. And in this model, economic growth is actually going to, in the long run, be exogenous. And it's going to be determined by this total factor productivity that we have seen already. As I said, the labor force is going to grow at a constant exogenous rate of N. Consumers are going to save a constant share of their income, and that is S. So that means that their savings is always going to just be S times income. Production is constant returns to scale, and it's exactly as we had it before. GDP equals the total factor productivity times this production function notation F, which now is going to depend on both K and N. Whereas before N was endogenous, now N is exogenous. And whereas before K was exogenous, now K is endogenous. Importantly, as we will see, both capital and labor continue to exhibit diminishing returns. Capital depreciates at a constant rate of delta. And that's just because machines get old, machines wear out, and what we are assuming, to make things nice and simple, is that they just wear out at this constant rate. There's no government, so whereas before we had that y equals c plus g, now we have y equals c plus investment. And remember that investment is purchases of new capital goods. Now what we're going to do then is we're going to compute both a steady state, which is going to be, we can think of this as the long run, and we're going to look at growth paths, which we can just think of as transitions between steady states. Okay, and we're going to then distinguish variables by the year that they exist. And we'll have variables at time t, and we'll have variables at time t plus 1.